Your web framework has middleware. Logging wraps authentication, wraps rate limiting, wraps your handler. Each layer adds one concern without touching the others. That is the decorator pattern. You have been using it every day without knowing its name. Decorator pattern. Low-level design. Day 12. The decorator pattern attaches additional behavior to an object dynamically by wrapping it. Instead of modifying a class to add features, you wrap it in another object that adds the new behavior and delegates the rest to the original. Think of it like Russian nesting dolls. The innermost doll is your core object. Each outer doll adds a layer of behavior. A logging decorator wraps your service and logs every call before passing it through. An authentication decorator checks credentials before forwarding the request. A caching decorator checks the cache first and only calls the wrapped service on a cache miss. The critical principle is that every decorator implements the same interface as the object it wraps. This means decorators are interchangeable and stackable. You can add logging, then caching, then rate limiting in any order. The client code does not know or care how many decorators are wrapping the real object. The structure has 4 parts. First, the component interface that defines the operations. Second, the concrete component, which is the core object with the real behavior. Third, the base decorator, which holds a reference to a component and delegates all calls to it. Fourth, concrete decorators, which extend the base decorator and add specific behavior before or after delegating. In Go, the pattern is even cleaner because interfaces are implicit. You define a notifier interface with a send method. The base email notifier implements it. Then a Slack decorator wraps any notifier, sends via Slack, and delegates to the wrapped notifier. An SMS decorator does the same for SMS. You can stack them. SMS wraps Slack, wraps email. Calling send on the outermost decorator triggers SMS notification, then Slack notification, then email notification, all through the same single send method call. Each decorator adds exactly one responsibility. Let me show a practical example with HTTP middleware, which is exactly the decorator pattern. You define a handler interface with a serve HTTP method. Your actual business logic handler implements it. A logging middleware struct wraps any handler. Its serve HTTP method logs the request, records the start time, calls the wrapped handler's serve HTTP, then logs the duration. An auth middleware struct wraps any handler. Its serve HTTP method checks the authorization header, validates the token, and only calls the wrapped handler if authentication succeeds. Otherwise, it returns a 401 error. A rate limit middleware wraps any handler. It checks the rate limiter, returns 429 if the limit is exceeded, and otherwise delegates to the wrapped handler. You compose them by wrapping. Your final handler is rate limit wrapping auth, wrapping logging, wrapping your business handler. Each middleware adds one concern. Adding a new concern means writing one new decorator. Removing one means unwrapping one layer. No existing code changes. When should you use decorator? 4 scenarios. First, cross-cutting concerns. Logging, metrics, tracing, and caching need to be added to many services. Instead of modifying every service, wrap them with decorators. Add logging to any service by wrapping it with a logging decorator. Second, HTTP middleware chains. Every web framework uses this pattern. Shy, Express, Django, Spring, they all let you stack middleware. Each middleware is a decorator that adds authentication, CORS, compression, or rate limiting. Third, stream processing. Buffered reader wraps a file reader. gzip writer wraps an HTTP response writer. Encryption wraps a network connection. Each adds one transformation layer to the I/O stream. Fourth, feature toggles. Wrap a service with a feature flag decorator that checks a flag before delegating. If the flag is off, return a default response. If the flag is on, call the real service. Enable and disable features without changing any business logic. Decorator is often confused with other patterns. Decorator versus adapter. Decorator keeps the same interface and adds behavior. Adapter changes the interface to make incompatible things work together. A logging decorator on a payment service still returns a payment result. An adapter for Stripe converts Stripe's response into your payment result format. Decorator versus proxy. Both wrap an object, but their intent differs. Decorator adds new behavior like logging or caching. Proxy controls access to the object, like lazy loading, access control, or remote proxying. In practice, the line blurs. A caching proxy and a caching decorator look almost identical in code. Decorator versus strategy. Strategy swaps the entire algorithm. Decorator wraps and enhances an existing algorithm. Strategy replaces the sorting algorithm from quicksort to merge sort. Decorator wraps the sorting algorithm with timing measurements. The key test is whether you are adding behavior to an existing operation or replacing the operation entirely. Decorator is one of the most used patterns in production. First goes HTTPS middleware. The standard library's HTTP.handler interface enables middleware stacking. Every Go web framework, including Chai, Jin, and Echo, uses decorators for request processing pipelines. Second, Java I/O streams, buffered reader wraps, file reader wraps, input stream reader. Each adds one capability: buffering, file access, character decoding. You can combine them in any order. Third, Python decorators. The @ syntax is literally named after this pattern. @login required wraps a view function with authentication checking. @cache result wraps a function with memoization. @retry wraps a function with automatic retry logic. Fourth, React higher order components. With auth wraps a component with authentication. With loading wraps it with a loading spinner. With error boundary wraps it with error handling. Each HOC is a decorator that adds one concern to any component. Fifth, gRPC intersectors. Both client-side and server-side interceptors in gRPC are decorators. They add logging, metrics, authentication, and tracing to any RPC call without modifying the service implementation. In interviews, here are the key points. If asked to design a notification system that supports email, SMS, Slack, and push notifications in any combination, use decorator. Each notification channel is a decorator wrapping the next. The client calls send once, and the chain fires all configured channels. If asked how middleware works in web frameworks, explain it as the decorator pattern. Each middleware wraps the next handler, adds its concern like logging or auth, and delegates. The execution order is outermost decorator first on the way in, innermost first on the way out. Know the difference between compile time and runtime decoration. Inheritance adds behavior at compile time. Decorator adds behavior at runtime. You can dynamically decide which decorators to apply based on configuration, feature flags, or user preferences. Common follow-up question: why not just use inheritance to add logging? Because you would need a logging payment service, a logging user service, a logging order service, one subclass per combination. With decorator, you write one logging decorator and wrap any service. This is the class explosion problem that decorator solves elegantly. 5 things to remember. Decorator attaches additional behavior by wrapping objects. Same interface, added functionality. Like middleware layers in a web framework. Use composition, not inheritance. Each decorator wraps a component and adds one concern. Stack decorators in any order for flexible combinations. HTTP middleware is the most common example. Chi, Express, Django all use decorator for authentication, logging, rate limiting, and cores. Decorator versus adapter versus proxy. Decorator adds behavior with the same interface. Adapter changes the interface. Proxy controls access. Real-world examples include Go HTTP middleware, Java I/O streams, Python decorators, React HOCs, and gRPC interceptors. The pattern is everywhere in production code.